So analysis of inorganic compounds, how we can identify inorganic compounds. We'll do questions, topic-wise question related to that. So the first part, compound A is a white solid. Whenever a compound is a white solid, this gives you an indication that it cannot be a transition element or there is no transition element. And it contains one cation and one anion is there. A flame test was carried out on compound A by mixing a solid with hydrochloric acid concentrated. Then using a piece of wire, a nichrome wire, we placed some of the solution formed in on the Bunsen flame color yellow. Name a material from which the wire is made and suggest one reason why we use that specific material. So normally we can use, like normally it's nichrome, nickel chromium alloy, or you can write any unreactive metal such as platinum. But commonly it's nichrome. And what is the reason for that? Because it is unreactive or does not react. So name of the material is nichrome, and what is the reason for that? It does not react or it is unreactive. That's why we use. Identify by name or formula the cation present. So the positive ion which is present here, as it is giving a yellow color flame, so yellow color flame gives an idea or indication that there is a sodium ion. Because I mentioned identify by name or formula, so when you're writing, so you should mention it is sodium ion, or you should write Na plus, because you have to, if you are using a formula, then Na plus. If you write only Na, you will lose that 1 mark. Why? Because Na is not the symbol for the ion, it is for atom. But we identify the sodium cation or sodium positive ion, so that's why it is Na plus. So either you can write sodium ion, Na positive ion, or you can mention Na plus. The next part, aqueous silver nitrate is added to a solution. It gives a cream precipitate, and cream precipitate dissolve in concentrated aqueous ammonia. So what gives an idea when you add silver nitrate and it's a cream color precipitate? It means this contain a bromide ion. And these precipitates are soluble in concentrated aqueous ammonia and insoluble in dilute. So the question is, name the cream precipitate. So you have to name a cream precipitate form when aqueous silver nitrate. So the precipitate which are formed are AgBr, silver bromide, and give a formula of anion in compound A. So what is the negative ion in compound A? That is bromide ion, so Br minus. If you write only Br, then you will lose the mark because they're asking for ion, it's not an atom. Then describe what would you see if a cream precipitate left in sunlight. So if we leave these cream color precipitate in sunlight, what we'll observe? We'll observe they will turn dark. The precipitate darken or the precipitate turn gray. And what is the reason for that? Because a photochemical reaction will occur in which the silver atoms are formed. That's why the precipitate will turn gray or dark. The next part, concentrated sulfuric acid. So we have H2SO4 which is concentrated, is added to compound A in a test tube. We observe a steamy fumes. So compound A, basically what we identify that compound A contains sodium and it contains bromide. And as a result, when we add H2SO4, as a result, it will produce sodium hydrogen sulfate. Acid base reaction will occur, plus HBr will be produced. Acids are proton donors, bases are proton acceptor. So this HBr is responsible for this misty or the steamy fumes. After a few minutes, the content of the test tube turned brown. Why the content of the test tube turned brown? Because as a result, this HBr which is given off, this hydrogen bromide, in which bromine is a good reducing agent, it will reduce the sulfur to lower oxidation state and can lead to formation of a bromine molecule and sulfur dioxide. So after a few minutes, the content in the test tube turned brown. So why the content turned brown? Because of formation of a bromine. A gas is given off which tested with a piece of filter paper which is soaked in aqueous acidified potassium dichromate. It will turn from orange to green. Identify by name or formula the steamy fumes. So what were the steamy fumes at the beginning? That was HBr or hydrogen bromide. Describe a further test to carry out the confirmation of identity. So hydrogen halides, how we can test? We can add aqueous ammonia or by using an ammonia solution. And as a result, when ammonia solution is there, what it will form? It will form a dense smoke. So there will be a formation of a dense white smoke because of that hydrogen bromide HBr reacted with aqueous ammonia or ammonia solution. As a result, it will produce ammonium bromide. It will give a dense white smoke. So whenever we want to test hydrogen halides, we test in this manner, that we can add or use aqueous ammonia or a bottle of ammonia nearby the test tube which is giving off hydrogen bromide. So we'll observe the dense white smoke is formed due to the formation of ammonium halide. Then identify by name or formula. Identify by name or formula substance that is responsible for a brown color. So which substance is responsible for brown color? So that is Br2 or bromine. Name the gas that turned the filter paper green, like acidified potassium dichromate from orange to green. So the gas is sulfur dioxide. When they say name a gas, so you're not supposed to write a formula, you have to write that it is sulfur dioxide. And the type of reaction, it is a redox reaction because this potassium dichromate, acidified potassium dichromate, in which the chromium is +6, it changes to +3. That is the reason why it changes the color as well. Is it clear, this question? So compound A is a white solid that contain one group 1 cation and one anion is there. Describe how would you carry out a flame test on compound A. It's of 3 marks. And this is a very common question you will find in exam as well, that the procedure to carry out a flame test. So first what we do, we take a nichrome wire or a platinum wire. That is one thing. Second, what we do, we will dip in concentrated HCl, hydrochloric acid. That is the second thing. And then we will take the sample and place on the hot part of the flame, or the hottest part of the flame, so we can see the specific color depending on which one, like which of the positive ion is present. According to that, we observe a color. So this always remains the same. The procedure never changes for carrying out the flame test. In a flame test, a compound give a red flame. Deduce the formula of the cation present. So it's a red flame. So as they already mentioned, it is group 1. In the beginning of the question, they specify that it is a group 1 element. So the group 1, because red flame can be calcium, the red flame can be for calcium, it can be for strontium, but we cannot mention that. Why we cannot mention? Because the calcium is group 2 element. But this in the beginning of the question, they mentioned a cation belongs to group 1. So a group 1 cation which give a positive, like a flame test, red flame, that is lithium. And deduce the formula. So if you write only Li, you will lose the mark because you have to deduce the formula of the cation. So these small informations are very important, like deduce the formula of a cation. So we are not supposed to write lithium atom, we should write Li plus. So some student, like, they understand the question and they just write Li, lithium. And one more thing, if you write, like example, if you write lithium ion, you will also not get the mark. Why? Because in the question they mentioned deduce the formula. So lithium ion is not a formula. The formula of lithium ion is Li plus 1. So you should write a formula. You should not write in words. Sometimes they give you both options, deduce the formula or state the name of the compound. So in that case, you have both options. But here in this one, it is Li plus 1. On a prolonged strong heating, a solid compound A forms a white compound A forms a white solid and a gas is given off which turns lime water milky. So this gives an idea that this compound is lithium carbonate, because carbonate and lithium decompose like group 2 elements. The lithium carbonate, when we supply heat energy, it gives off lithium oxide and carbon dioxide. It decomposes like same manner as the group 2 elements like calcium, because lithium ion is smaller in size, so it's caused more distortion to the carbonate ion. As a result, it can thermally decompose at a lower temperature as compared to sodium or potassium, and thermal stability as we go down, it increases. So identify by name or formula. So here we have both options. Either we can write the name or we can write a formula. The compound that dissolve in water to make lime water. So which compound we dissolve in water to prepare a lime water? So basically that is slake lime or calcium hydroxide. Calcium oxide is also acceptable, but normally what we do, we dissolve calcium hydroxide, a solid calcium hydroxide dissolved in water to make a lime water. We don't have to mention a state symbol, just the formula, or you can write calcium hydroxide or slake lime. Suggest the formula of anion in a compound and justify your answer. So what could be the anion? So the anion here will be carbonate, or it can be hydrogen carbonate, because both possibilities are there, that lithium carbonate or hydrogen carbonate both can decompose and give off carbon dioxide. So suggest a formula for anion. So we have to write a formula. So if you write CO3 with a charge 2 minus, you will score the mark. And justification for this, why we say, because the thermal decomposition give off carbon dioxide. So the thermal decomposition of this compound, what happened? It produced carbon dioxide or CO2. So that is a justification for point, like identifying that it contain a carbonate ion. The next one, when water is added to a white solid B, what is the solid B? As you can see in the beginning, the solid A was lithium carbonate. When we supply heat energy, it become lithium oxide. So lithium oxide dissolve completely and exothermic to form a solution C. So identify by name or formula of the anion present in B. So if we have lithium oxide, we dissolve in water, it will form lithium hydroxide. And we have to identify by name or formula the anion present in B. So basically lithium oxide, first it was lithium carbonate. When we supply heat energy, it turned out to be lithium oxide and carbon dioxide. That lithium oxide is compound B. In compound B, we add water, it turns into lithium hydroxide, form an alkaline solution. So identify by name or formula the anion, the negative ion present. So in B, what is the anion? It is oxygen. And identify by name or formula the anion present in C. So it contains OH or hydroxide. Suggest a test to test the presence of anion OH group. So how we can test the OH group, because this OH is not like for the organic compounds, this is inorganic compound OH, or it's like how to test that whether the solution is alkaline. So what we can do, we can add a universal indicator. It will show a color like blue or purple. So add universal indicator. And it will show, because it's a strong alkaline solution, so it will show blue color or purple color, or the pH will be around 11 or 12. Then test and result, and suggest a formula of compound A. So compound A, we already worked out that lithium was there and carbonate was there, so it is lithium carbonate. Is it clear, this question? Any part you have doubt or a question related to this? So in this question, a white solid A contain one cation and one anion. A small amount of solid A was placed in a test tube and aqueous sodium hydroxide is added. The mixture was warmed gently. Complete the inference column in the table. A pungent smelling gas was evolved that turned red litmus. So it means the gas which is given off is ammonia. And whenever we add an alkali, ammonium salt, so this gives an idea that this is an ammonium salt, because ammonium salt, they gives off ammonia when we add a sodium hydroxide. So the gas formed is ammonia, and the formula for the cation which is present is ammonium. And if I write NH4, it is wrong, because I should mention it is a cation, and they are writing in bold formula. So if a student write ammonium, like words student use ammonium, so you will also lose the mark, because it is bold as formula or mentioned as formula. So you have to use a formula. So formula for ammonium ion is NH4 with a charge 1 plus or plus 1. So these small details, when you're answering a question, you should consider these details and don't like miss these details. The next part, so we identify that this compound contain ammonium ion. Then an aqueous solution of A was placed in a test tube and acidified nitric acid, few drops of silver nitrate. So inference, it's a cream precipitate. So cream precipitate are due to formation of silver bromide, and it gives an idea that A contains the negative ion is bromide ion. So the precipitate is, what is the precipitate? The precipitate is silver bromide. And write ionic equation, include a state symbol for formation of cream precipitate. So what happened when silver ions, which are aqueous, reacted with bromide ion, which are also aqueous? As a result, it will form AgBr, which is solid. That's how when we mix the two solution and a solid is formed, we call that solid as PPT or precipitate. So this precipitate is for silver bromide. And compound A, now we confirm because it mentioned already that there is one cation and one anion. So one of the ion is ammonium, another one is bromide. So this compound is actually ammonium bromide. Then describe how would you confirm the identity of the anion. So how to confirm the identity of the anions? These anions, like if we want to say that there is a bromide ion is present, so we can add concentrated aqueous ammonia, because the precipitate, or first we add dilute aqueous ammonia and the precipitate does not dissolve, and then we'll add concentrated aqueous ammonia, the precipitate will dissolve. So to confirm, because in dilute it is insoluble and concentrated it is soluble or partially soluble, so add dilute aqueous ammonia, the PPT will not dissolve or does not dissolve, and then we will add concentrated aqueous ammonia, the the precipitate will dissolve partially, we can also mention, or even you mentioned dissolve, that is if it was silver chloride, then both cases, even it's a dilute or concentrated, both cases it will dissolve. And if it was silver iodide, when we add dilute or concentrated, it won't dissolve at all. So another question, the use of ammonium carbonate in smelling salt is due to the formation of ammonia gas, which counter the effect of that cause fainting. So when ammonium carbonate is heated, gently decomposed to form ammonia, water, and carbon dioxide, write an equation that for the decomposition of ammonium carbonate, state symbols are not required. So first, what is the formula for ammonium carbonate? Ammonium is a valency +1 and carbonate is a valency -2. So ammonium carbonate, the formula for ammonium carbonate will be NH4 in a bracket 2 CO3. So when we supply in the heat energy, when we heat it, as a result, what it form? It gives off ammonia gas. As I mentioned here, it produces water and it produces carbon dioxide. But the equation, whenever you have an equation, symbolic equation, it must be balanced. So we have two ammonia ions here. So we need two, like we have two nitrogen ions basically. So we need two. So I put two here. Nitrogen is balanced. What about hydrogen? 4 multiplied by 2, 8. So 3 multiplied by 2, 6 and plus 2, 8. Carbon is 1, that is balanced, and oxygen is 3. So 2 plus 1, 3. So this equation is balanced in terms of all the elements. The next part, complete the table, give a chemical test not involving indicators and its result for each of the product for decomposition of ammonium carbonate. So how we can test ammonia, how we can test water, and how we can test carbon dioxide. So a chemical test for ammonia, as I mentioned, we cannot use indicator. So what we can do, we can react with hydrogen chloride or hydrogen bromide or hydrogen iodide. When this ammonia react with these hydrogen halides, so chemical test, we can react with hydrogen halides or any specific you can mention, like hydrogen hydrochloric gas or hydrogen chloride gas, and as a result what we'll observe, ammonia plus hydrogen chloride, it will produce ammonium chloride, and it will produce a dense white smoke. Then chemical test to check the presence of the water. So we can use anhydrous copper sulfate or cobalt chloride. If we are using copper sulfate, it will turn from white to blue. And in case of cobalt chloride, it will turn from blue to pink. So to test the water, we can use anhydrous if I'm using copper sulfate, so or copper to sulfate, as a result, what will happen? It will turn from white to changes the color from white to blue. If it was cobalt chloride, it will turn from blue to pink. Then test to check the presence of the carbon dioxide. So we can test with a lime water and it will turn cloudy or milky. The next part, complete a diagram to show how you would collect carbon dioxide obtained by heating ammonium carbonate using another test tube as only the additional apparatus. So we can only use a test tube as an additional apparatus, and here we are heating ammonium carbonate. So what we can do, because carbon dioxide, we cannot attach any. Carbon dioxide is a dense gas. So if it's a dense gas, if we were collecting a gas which is lighter, example, if it was producing a gas that is lighter, and we have only, as I mentioned, we have only available apparatus is a test tube. So we'll place the test tube, inverted test tube, near the mouth. We should place a test tube like this if the gas which is given off is lighter than air, because when gas is released, it will go up. But because the carbon dioxide is heavy, so how we should place a test tube? We should place a test tube in this manner. So they're just using your concept or idea that about the density of the gas. Like if it is lighter, it will rise up because the dense gas, because due to heat, it is rising, but it cannot go further. So it will be there in the other test tube. Some of the gas might escape, that is a possibility, but because you don't have any apparatus left, so you cannot just completely make the test tube up. Otherwise, like if you can connect this test tube directly mouth to mouth or neck to neck, then it is also wrong. Why it is wrong? Because according to this technique, you can never collect a carbon dioxide. When carbon dioxide gas is given off, it is denser, so most of the carbon dioxide will be here. That's why the other method, this one will be considered as wrong. The next part, a sample of ammonium carbonate was dissolved in water. A sample of a table, complete the table to give the expected observation and identify the observed product. So we add 1 cm cube of barium chloride and the solution was tested, was added to 5 cm cube ammonium carbonate. So as a result, it will produce barium carbonate and barium carbonate and barium sulfate. They are, what will the observation? It will be white PPT and observed product is barium carbonate, BaCO3. Then we add hydrochloric acid to the mixture in one. So if we add hydrochloric acid, the carbonate will decompose. Observed product means the product which we can see. That's the observed product. So when carbonate plus acid, it will give bubbles, phase or effervescence. And the observed product is what? The product which we can see. So here we can write observation will be phase, bubbles, and the observed product is carbon dioxide. But you should write, because they did not specify here, write a formula. So in that case, it's better you write in words. Acceptable is there, like our formula is acceptable, but and if they did not mention, it's better you use the words to write the answer. Is it clear, this question?